Hello everyone. Today I'm going to solve a Cauchy-Euler differential equation with initial value, or they call it Cauchy-Euler equation initial value problem, like the one that I showing you in the top with the green color, x squared times y double prime minus 5x y prime plus 8y equals 0 with y at 2 is equal 32 and y prime at 2 equals 0. So how we can approach to solve these types of equation? So at the first step we are assuming that the y that we are gonna find for this differential equation has a form of y equal x to the m, and then we can find y prime and y double prime to plug all the y and y prime and y double prime in the original Euler equation to find the right and the best m for this case, because m is unknown, we don't know anything about it. But by substituting this y prime, y double prime, and y in the first line of equation, we will get something like this line, you know, and everything is clear in this line. So, by multiplying this x to x squared to the xm minus 2, we will get xm, and this x to the xm minus 1, we will get again xm, and we get take out all the xm from all the terms in this line. So after taking out the factoring xm from this line, so the first term we'd left with m times m minus 1, and the second one would be m minus 5 times m, and this one plus 8 should be equal 0. And after simplification we would get something like this line. And since we are looking for some guess for y as a x to the m, and this y should not be 0, or in other way we are looking for some non-trivial solution in more specific case, because we have y at 2 is 332, so y should not be equal to 0. That's why if y is not equal to 0, this xm should not be 0, right? Okay, if x to the m is not 0, this line, when we say that this times this bracket inside terms inside the bracket is 0, it means this should be 0 or that should be 0, or both. But we know that this cannot be 0 because y cannot be, is not trivial. That's why we are concluding that this terms inside the bracket should be 0. It means m squared minus 6m plus 8 equals 0. So how we can solve this equation? So there are different way to get it, but the easiest way is the, this types of factorization part, or you could do some quadratic formula or something like that. And finally, in any method you will get two different solutions for m, which we call m1 as 2 and m2 as 4. Okay, so if we get m1 2 and m2 4, which means we get some two different solution for this y equal x to the n, right? So we can say that, okay, if one x to the m1 is a solution and x to the m2 is another solution, so the summation and multiplication of that solution, multiplication of that solution times c1 constant is is again the solution of that ordinary differential equation. And the second one, the same idea. So it means if we had the x m2 is a solution to, so after multiplication of c2 as a constant to the x to the m, again we have the solution of the original ODE. So that's why we get c1 x squared plus c2 x to the 4. But C1 and C2 is not known at this moment, but we can find it on the top. As we can see, we have an initial value problem. So we have y at 2 equals 32 and y prime at 2 equals 0. So if y at 2 equals 32, it means this line, right? So if y is 32 at 2, just plug x at 2 and we would get c2 plus 2 to the fourth, and finally we would get this green one. 32 should be equal to 4c1 plus 16 c2. And by imposing the second condition, which is y prime at 2 equals 0, so at the first step we need to find y prime from this line, from the star relation, right? So y prime would be 2c1 x plus 4c2x to the x cubed. Okay, by this way, if because we know that y prime at 2 equals 0, so 0 equal y prime at 2. Y prime, as I said, is 2c1x, which is 2 plus 4c2x to the third. So, and finally we will get 0 should be equal to 4c1 c32 c2. And now, so to find the right, c1 and c2 two from these two differential, system of these two equations. So we can solve this kind of system of differential equation, and we can find c1 and as 16 and c2 minus 2. So if c1 is 16, so by considering this um, star relation, just plug this c1 as 16 and c2 as negative 2. Finally we will have y equal this, right? So y should be equal to this one, 16x squared minus 2x to the fourth. And that's the solution for the main problem in the top, as they call it, Cauchy-Euler equation, initial value problem. Thank you. If you like the video, please subscribe and hit the like button, and please feel free to ask your specific question, and I will get back